Okay, well I think we're just gonna, in the interest of time, we're just gonna dive in and get started. Okay, so how do you contribute to Zen? The first thing to emphasize is to say that we want your patches. Okay, a lot of people feel like, well, this is an open source project. You know, I'm bothering people by sending my patches. Not really. We do actually want your patches. Why do we want your patches? Well, first of all, just as individuals, it feels good. If you're using the stuff that we write, it feels good for us to know that it's useful and to know that you care enough about using it to actually improve it. But of course, most of us are paid to work on Zen, which means, and we're not paid to feel good, right? Our employers want your patches too. Why do they want it? Well, first of all, every additional person that uses Zen adds to the Zen mind share and the Zen brand. Okay, so the more people use Zen, the more other people will use Zen. And also, a lot of our things have Zen in the name. So the more people use Zen, the better Zen server looks. The more people use Zen, the better Zen Zuza or Oracle or whatever looks. Furthermore, we may actually want to use your code someday. If there's a thing that Zen doesn't do that you would like it to do, maybe there's a thing that Zen doesn't do that our customers would like it to do. So for all these reasons, we actually do want your patches. That said, we often talk about free software. We say that free software is free as in free speech. We might say that free software is free as in free beer, like it doesn't cost any money. But for a maintainer of an open source project, free software is often free as in free puppy. Okay, so who here has ever owned an animal? Like, no? How many animals? Right, okay. So if you've ever actually owned an animal, you know that actually, even if acquiring the puppy is free, keeping the puppy is not free at all. Okay, it's a huge commitment in terms of time, money, and all kinds of things. So it's the same thing true for maintainers, right? So every additional line of code that we add to Zen makes it more difficult to change and refactor. It makes it, there's a higher chance that there's going to be a bug that needs to be fixed. And it's typically the case, particularly if there's a new submitter, that a submitter will come, they'll submit a change or a feature, and then they'll disappear and never be seen again. So I, as a maintainer, whenever I'm looking at your code, I'm thinking, I'm going to have to maintain this. It's going to cost, it's free as in free puppy. Is it going to cost me something? So, so there is this tension, okay? We do want your patches, but at the same time, your patches cost us a little something. So keep that in mind as you are submitting. Okay, so how does any patch get in? So the first thing to talk about is the concept of maintainers. So Zen is big and complicated enough that there is no one person who understands the whole thing. And this leads to something I call the one little change problem, okay? So you have a big, giant system that nobody really understands completely. Someone else wants to come and add something to it, and they look at this thing and they say, like, that's big and scary, I want you to change as little as possible. So instead of actually figuring out sort of how it works and the best way to insert something in there, they come in and say, well, I'll just add this little bit on the outside here. So a little exception, it's really small, only does one little tiny thing. And then whoever's looking at this, the maintainer says, it does the job, I guess I don't understand how to change things either, I'll just add this one little thing. And then you add one little thing, one little exception, one little exception, one little exception. And pretty soon you have a big, unmaintainable mess. So the idea of maintainer is to have some person who has a long-term investment in keeping the code clean, right? It's their job to understand that little corner of the code. It's their job to make sure that that code stays maintainable and understandable. And you can find the maintainers in the Git maintainer file. And there's also a couple of useful scripts in here. So git maintainer.pl and this is the one add maintainer.pl. The other thing to say is that there's a concept of nested maintainership. So some areas are large enough that sub-areas of them, they have entire sub-areas that need their own maintainers. Okay, so Jan and Andy are the x86 maintainers, but inside the x86 maintainer, I am the MM maintainer. Okay, so it's my job to take care of and understand the MM code. inside the NM code, there's the shadow code, which is maintained by Tim Deegan. Okay, so yes, and there's a number of things that don't have a specific maintainer, and for that you look at the thing called the REST. Okay. Okay. So when is a patch actually allowed to be checked in? So basically, to check in a patch, you need approval from all the maintainers whose code the patch touches. So if you have a patch that touches the generic x86 code and the scheduler, then you need an app from the x86 maintainers and from the scheduler maintainer. You also need the approval, or at least the acquiescence, of anyone who has ever raised an issue. Okay, so if you posted a patch and someone who is not a maintainer has raised an issue, normally that patch won't be checked in until that person has said, yes, I'm fine with it. So the next thing to talk about is a role called the committer. So technically speaking, committer is a secretarial role, right? The job of a committer is to keep track of the patches on the list and make sure that when they have all the acts necessary to be checked in, to actually check it in. But because committing means you have to actually have the access to log in and actually do the check-in, it implies a certain amount of trust. Okay, so not anyone can become a committer. You have to be, because it implies access to this resource, it applies a certain level of trust. And so we have actually just made this role add an additional role to this, which is a kind of a final authority or elder council role. There at the moment, there's 7 or 8 different committers, and I'll discuss more about those roles later. Oh, it's actually right now. So now, in general, in the Zen community, we try and do things by consensus. Okay, which means we should have a discussion and we try to reach a point where everyone says, "Okay, I agree with that." Now, consensus cannot always be reached. Sometimes two people are just going to disagree. So we have to have a fallback to happen in case that there's disagreements. And so there's different levels of conflict resolution here. Okay, so first of all, maintainers can overrule non-maintainers. Okay, so if there's a patch to the scheduler, I'm the scheduler maintainer, and Andy says, I think we shouldn't do that, or some other person who's says, I think we shouldn't do that. We can go back and forth, but after a while, if we don't agree, then I just get to decide. I can say, you know what, we're going to do it this way. Okay, so maintainers can overrule non-maintainers. Nested maintainers can overrule or stand in for higher level maintainers. Okay, so if Tim Deegan, the shadow code maintainer, might say, I think this is a good idea, I can overrule him as the Emma maintainer and say, no, we're not going to do that. And then Jan and Andy, who are the x86 general maintainers, can then overrule me and say, yes, we are going to do that. Or if Tim isn't there, I can hack it, and if I'm not here, then the x86 maintainers can hack it as well. And finally, the kind of final fallback, if there's still things that can't be resolved, is a majority vote of the committers can overrule a maintainer. Now, the reason I've put these in different levels is because any kind of overruling it's best to be avoided, right? So the person who is being overruled loses a certain amount of face. They have a certain amount of it's just not very nice to be overruled. So we generally try to avoid that if we can. Okay? And obviously, the more higher up this goes, the more level of kind of an insult, right? So if the maintainer overrules a non-maintainer, it's kind of like, okay, that's not too much unexpected. But if the committers overrule a maintainer, that's actually difficult for me to imagine a situation where the maintainer says, I insist this be done this way, and the committers overrule them, and that person continues to be a maintainer, right? If I were in that situation, I would leave the project, right? So, but on the other hand, because we have this escalation, because there's an escalation path there, people normally, we never have to actually access it, right? So normally, when there's a discussion going on, if people can see this is the way things are going to go, they don't bother to actually go to the escalation process. They just say that because they don't want to be overruled, they just actually achieve consensus. Okay. Okay. All right. So, are there any questions about this? Make sure this is clear. Okay, the next thing to say is just expect iteration. There's a very low probability, even for people who are core maintainers, to send a patch and have version 1 be accepted. I think basically every line in your patch will decrease the probability of that by 25% or something like that. So if you have a 4-line patch, there's four lines of changes. There's a pretty small 25% chance that we check in without changes. And if it's a big patch, there's basically a 0% chance, even if you are a core maintainer. So just expect to have feedback. The next thing to say is when you can submit your patches. So at the moment, our development window is essentially divided up into 3 kind of phases. Okay, so we have open development, which means any patch which has the appropriate apps can be checked in. There's a small window, normally about 2 weeks, between what's called the last posting date and the feature freeze. Okay, so during that window, patches can only be checked in if they have all the apps and at least one version has been posted before. Does that make sense? So if you don't have this last posting date thing, if you just say here's the feature freeze, then what often happens is basically the feature freeze is on a Friday. On Thursday and Friday, everyone submits all their patches, and then you have the maintainers frantically trying to review all the patches to try to get them in before the feature freeze. Okay. So what the last posting date does is everyone should mash to get version 1 of their patch done by the last posting date, and then we have 2 weeks to actually iterate and fix all the little tiny bugs before we do finally the feature freeze. And then of course we have the feature freeze, which normally lasts 6 to 8 weeks, in which only bug fixes can be checked in. Okay. At the moment, we only do 2 releases per year, every 6 months. It's scheduled in June and December, so you can always predict ahead of time the feature freeze is going to be here, the last posting date is going to be here, and so you can plan months ahead of time when you need to push to get your code done. That said, we are going to be having discussions this afternoon about changing that. So many people have said 6 months is too short, maybe we need 9 months or a year. Okay, how do you write a good patch or a good patch series? The first thing to say is there are 1,000 unwritten rules. Okay, even if we could write down all those rules, you wouldn't. It would be a massive book, and you would never get through it. And even if you did somehow get through it, you would forget all of it by the time you got to the end. So the only way to learn all the unwritten rules is to be told them as you break them. Okay, so I wish there were a better way to do this, but I just can't think of a better way. Okay, so basically, you just have to submit your patch and accept that you're going to accidentally violate a bunch of different rules, and we'll just tell you, right? So don't worry, you're not going to get it right the first time, or it's going to take a while before you really get all the rules kind of down. So don't worry about that. When you're writing a patch, consider 3 audiences. Okay, the reviewers, the people who are scanning through the code, and archaeologists, people from the far distant future who are going back in time and trying to figure out how the code got to be the way it is. Okay, so let's consider the reviewer. Okay, the reviewer has a patch that they're looking at it, and they say they want to have a couple different questions. Right? Is this patch necessary? Right? Does it actually fix something that needs to be fixed, or could this be done differently? Is this patch the right way to solve the problem? Okay, is there a better way to solve the problem? And also, is this patch correct? Will it break anything, or does it actually do what it's saying that it's doing? Okay. The next audience is someone just scanning through the Git commit history, looking for things. So they may be looking for patches to backport. Maybe they've noticed that something's broken and they're trying to figure out which patch broke it. Maybe they notice that something is broken and they're looking for a patch which fixes the problem. Okay, they'll be looking at something like this. Okay, like a Git log, which just has one line thing. Right. So say that I've pulled my something and I've noticed that suddenly my Vif stuff's working. Right. So I might scan through here and say, okay, tools, utility, Zenstory. Right. Oh, right. Okay. So the Vif is attached stopped working. That uses Zenstory. Maybe that's something to look at, right? You can just skip there, say arm. No. Okay, right. So the idea is people are scanning through here, and that they need just enough information to tell if they should look deeper. for whatever reason. And the final person to consider is the archaeologist. This is going to be someone earlier this year, I found a piece of code, and I didn't understand why it was written that way, okay? And so I looked back in time and found out who the original person was that introduced it. And it was first introduced in like 2006. So I found the original commit from 2006 that described what was going on, and that told me, yes, it was okay for me to change it, right? There's a principle called Chesterton's fence, which is you should never take down a fence until you know why it was put up, okay? If you see the code and it's this way, you shouldn't, sometimes you just can't figure out why, right? But in general, before you try and change something that you don't understand, you should try and understand why it got that way in the first place. Because maybe it was done for a good reason that time, and that things have changed. Now it doesn't matter anymore. Maybe it was done for a good reason, and actually that reason is still valid, and you should change. You should leave the code. Okay. So think about the future. The person, a year, 5 years, 10 years in the future, who is coming back to look at your code and trying to figure out what's going on. Okay. So for me personally, I have a general template for a changelog. Okay. So first of all, I want to say, what is the current situation? What does the current code do? Okay. Why is that a problem? Okay. So first you say, what happens? Why is that a problem? And then say, how does your patch fix it? Okay. This is, if you look at my changelogs, almost all the changelogs follow this exact template. And then of course any other changes that the patch will change. And we'll have an example in a minute. The next thing to say is that have a good one-line summary. Okay, so generally give the area of the code that it's in. Okay, credit to, maybe max, and then colon. And then enough of a summary to have someone that's just looking at that one line to know whether it's worth looking deeper into what the patch is doing. Okay, so here's an example. It's a bit difficult to read. It says this comment.sh have IP tables for the X tables log. So anyone just scanning and just seeing that knows this is something about IP tables, something other than this. Okay. IP tables has a system-wide lock on the X tables, right? That's just a description. Strangely, though, in the case of two concurrent indications, the default is for the instant smart correcting the log to exit out rather than waiting for it. Okay, so I'll just describe the situation, and then I say, well, why is this a problem? Okay, when there's a large number of things starting in parallel, you may fail out the messages like this, and then I print the message. Now, one reason for that is that now if someone finds that message, they can do a Google search for it, and this patch will immediately come up, right? So now I said, why this is a problem? And the reviewer can immediately, if they don't believe me, they can just do man IP tables and say, oh yes, that is true. And then it's obvious why that's a problem. And then now we say, okay, what are we going to do about it? And in order to instruct IP tables to wait for the lock, we have to specify -w. Unfortunately, not all versions of IP tables have the -w option, so on the first invitation, check to see if it accepts the -w command. Now basically, with this thing, you already know what the patch is going to do, right? You know, it's .sh, so it's going to be a shell script. It's going to be something to do with IP tables. You're going to have the -w command, but first you're going to check to see if the -w command actually works. So now, when you actually look at the patch, it's just a matter of confirming. Does this do that? Yep, done, right? So that's why my sort of template, I think, the template is a good template which satisfies all those different people. Okay, so the next thing to say is when to break things up into a series. Okay, it's often the case that a full change, like to implement a full feature, may require several conceptually independent changes, which kind of little chunks of things that work together, right? So you may have change A, which covers 3 different areas, change B, which covers 2 different files, and change C, which covers 2 different things. And if you just do the patch, one big patch, that looks like A1, B1, A2, C1, C2, B2, D1, A3. So the reviewer looking at that has to figure out, they start to look at A, but they have to figure out which of the parts that work together. How do I make sure that this is actually doing what it should be doing? It's difficult for a viewer to sort of do that. And it's also difficult for an archaeologist coming back in time to look and see what's actually going on. So if you can, break it down into logical chunks. Have one patch that has A1, A2, A3. another patch that has B1, B2, and so on. And then that way, the reviewer immediately can see all the things that work together and say, yes, okay, I verified that's correct. And the next one, yes, I can see I can verify that's correct, okay? Okay, another thing to say is the importance of bisectibility. So bisection, if you're not familiar with it, is a very powerful way to find out when something broke, okay? So say that you did a pull at this point and your thing worked, and a month later you did a pull at this point, you merged your stuff and it broke it, okay? Well, you just say, okay, well, it worked here, it's broken here, let's try here. Oh, it's broken there too. Let's try here. Oh, it worked there. And then you sort of, very quickly zero in on the problem. The problem is that this only works if every change set actually works. Okay, so imagine, okay, it didn't work here, so it works here, it didn't work here. Let's try here. Well, the build breaks. Okay, well, let's try here. Well, the DOM0 crashes. Okay, well, let's try here. Well, that worked. Okay, well, let's try here. You see what I'm saying? Okay, suddenly it becomes a lot more work to do the bisection. So break your series down into less chunks, but never break existing functionality. Okay, you can don't introduce bugs in one patch and then fix them in another. Okay, so if you do patch 1, you do patch 2, and then while you're doing patch 3, you notice that there's a bug in patch 1. Go back and fix it in patch 1. Okay, don't fix it in patch 3. You are allowed to introduce code that isn't used, right? So sometimes you want to introduce code in patch 1, but you don't actually use it until patch 3. That's allowed. But you must never introduce code that isn't built. Okay. Quickly, just about coding style. Follow the coding style. That is just for fun. We have actually 2 different coding styles for the different parts of Zen, but none of these are very long. So just take a second, read through the coding style, and follow it. It shouldn't be too hard because people do care about this stuff. Okay, mechanics. I'm not going to go into detail a lot of this stuff, but just to give you some things to look at. Easiest way to get mail on the list is get sent email. Okay, I'm not going to describe that in detail. The man page is pretty useful. One of the things about it though is it's useful to know is there's in the commit message, if you put 3 dashes, dash, something starting with that, everything after that, so that there are tools, so get sent email is a way to get stuff from your Git tree out onto the email list. There's another tool called get.an, which will take things from the email list and put it back into a Git tree for you. And get.an, anything after the dash line will be thrown away. So you can use that to put things that, to put information that you want to give to the reviewers, but not necessarily to be checked into the tree. The other thing that's very useful that I've found is you can put, say, CC. So if in your change set you put CC and an email address, then when you do get send email, Git will automatically add that email into the recipients list. Okay. So going back to our example, so here we have this little description, and we have 3 lines here. Okay. I'll talk about this in a second. But basically, this is version 2 of the patch. So all the stuff here will all be completely thrown away when it's checked in. So I'm describing version 2 of the patch. What's changed between version 2 and version 1. I have a little comment here. Okay, the other option would have been to do that, but I don't want this to be checked in. This is just for the reviewers. And this is modifying the tool stack. And so here are the reviewers. And so I've added CC injects and CC prelude, so that when I just do get send email, and automatically those guys are CC. Okay, what to put in a changelog, what not to put in a changelog. You may reference already public commits. Okay, so you put the commit hash plus maybe a short type. Okay, so here's an example. Put the commit hash so they can easily find the git commit. It's also useful to just put a little quote there so people have a vague idea what this commit is actually doing. If you're going to reference previous discussions, try to summarize the previous discussion in the changelog. Okay, so if you write, if you're in a changelog, you're just like, as discussed on the list, we're going to do this. And you don't say why. You don't have a summary of the discussion. Now in 5 years' time, someone is going back in time and trying to figure out why this is the way it is. Now they have to go back and try and find the discussion on the list. Okay? So you should always at least summarize in the changelog what the conclusion of the discussion was and why. And you can include a link to the actual sort of URL of the discussion below the -- line if you want to help people who are reviewing. If you need a reference manual, so the Intel and AMD manuals, the references are designed such that they don't change. Okay, so if you have volume 3, 4.4.1, no matter how many more things they add to that manual, and now it's like what, 4 or 5 volumes, it's massive. 4.4.1 will always be the same topic in the same section. Okay, so you can put this kind of reference in there and know that even 5 years in the future, 10 years in the future, that's going to still cover the same topic. Okay, reposting, add a version number, so version 2, version 3, whatever. Get sent email makes this pretty easy, so you can look at the net page for that. And as I said, it's very helpful, and most reviewers will insist that you list the, so if there are changes between version 1 and version 2, version 3, most reviewers will insist that you list the changes between them, so that they can, because often what I do as a reviewer is, when the next version of the thing comes out, I've often forgotten, I mean, I'm just quite busy, right, so I've often forgotten what I said 2 weeks ago. So usually what I'll do is I will go back and look at the original discussion, see what everybody has said, and then I'll look in the thing and say, have they actually done all the things that people told them to do? Or explain why they're not going to do them, right? And then it's just a matter of verification, it's much quicker. Your all-purpose pass for making things if you're not quite sure what to do, your all-purpose pass for allowing things to happen is called RFC. This means request for comments. It makes it clear that you don't expect it to be checked in as it is, and hopefully it means that people will not do a super detailed, line-by-line thing of like coding stuff, that kind of stuff. We'll just give a general idea of what they think of the patch. For larger changes, it's frequently useful to have a design document. Okay, so we actually have documents that we can check and retrieve. So if there's a large, complicated patch, you might want to have a document that says, lays out in detail the situation, explores all the different options, and then say, this is what we're going to do. And finally, just dealing with maintainers, the communication style for maintainers, often we're just kind of busy, and we want to get things be directed to the point. So usually, I mean, in the Zen community, we generally try to say thank you for the patch first, at least, but sometimes we forget, and we just start saying what's wrong with your patch. Sorry, okay? We don't mean anything harm by it, we're just trying to be quick and efficient. So unusual but okay is short and direct, okay? One thing that is not okay is demeaning, okay? If anyone on the list says you are stupid or says something bad about you as a person, okay? Or even says something insulting about your code, right? So like Linus, a lot of the things that he posts on his list wouldn't really be acceptable on our list, okay? So if you, that kind of stuff is not okay. Kind of a judgment call sometimes is a maintainer being unreasonable? There's different opinions, right? Everyone who drives faster than you is maniac, and everyone who drives slower than you is an idiot, right? The same thing happens with code. Everyone who is more strict than you is like, being unreasonable, and everyone who is less strict than you is a cowboy, okay? So there's kind of a range of stuff. If you think you have a problem, okay, particularly if anyone is being demeaning or something like that, then contact the manager. And if you think a maintainer is being unreasonable, also contact the community manager. They can talk to the maintainers or they can talk to the committers and decide what's going to happen. And the last thing is just, if you post a patch and haven't heard anything in 2 weeks, just respond to your own patch and say ping, okay? It probably fill out people's lists, so if you, we can't leave it up to the, if the patch is important to actually check in, we figure, you're going to change it, okay? So if you haven't heard anything in maybe 2 weeks, just say ping, and that should get a priority. And so how much time do we have for questions?
The other session just ended, so just do a couple of questions when people stop. Just
People go ahead. Okay.
I mean, it'll eat into lunch, but we'll be fine.
Okay.
Right?
Okay. So sorry. Questions?
You mentioned the somebody being the meeting or whatever, contact
Lars Grove. Yeah. Well, or one of the committees, right? But I think Lars in general is the. Well, he's the takes care of the fuzzy side of things, you know, the softer relational side of things. Yeah.
Yeah, I'm a people person. I don't know the code, so and well, so I have written scripts and stuff, and I've gone through upstreaming stuff myself, only recently, and I know some of the.
Yeah. I mean, there's lots of people who are whatever. More or less, it's Lars's kind of job to be the more,
I forgot what your slide said. It said contact the.
Community manager. Yeah.
Yeah.
So Lars is the community manager.
Well, it's one of the things I do. Yeah. So
Yes.
I'm lots of things.
Yeah.
A couple of quick questions. So for a newbie, right? I mean, we have not developed in the open source, like in some cases, right? So if I want to pick a problem, like what is the way? I mean, is there a bug list that you go? Or is that based on my interest? I mean, basically, it's a more generic question. And secondly,
well, so can I start with it? So the first part of the question is, if you want to jump in and start to do something, are there lists of bug lists or lists of short projects, things to do? No, there's not a very good one. Maintaining that takes time, and we're all kind of busy. We sort of don't have a lot of time. So there are a couple of things. So we do have, if you post and say, are there any bugs? Someone might be able to find something. We do have a bug list. It's not very complete. But we do have a Jira instance that has some bugs in it, and a lot of those are kind of smallish things that someone who is reasonably competent but not necessarily familiar with Zen could pick up and do. If you want slightly larger things, then we maintain a list of potential projects for Google Summer of Code or outreachy interns to do. So if you wanted a slightly larger chunk, then you could do something like that. For small things, so we have a handful of things on our Jira, and if you ask on the list, then that will prompt people to put more things on the Jira.
Okay.
So second, does that answer your question?
yes, thank you.
And
So second one is like regarding testing. I saw like in one of the documents within SN, right? So is there a set of test cases that it's supposed to run, or is it automatically run? Like you say unit test, you need to, obviously engineers have to unit test their code.
yeah.
But more like a higher order bit, like what is the typical, what do you expect? So
For testing. So, right. So we're bolting on unit test after the fact. So it takes a lot of work, and it's much easier to do as you go. And in the beginning, we didn't do any kind of unit testing at all. So at the moment, there aren't really any unit tests in Zen. There's a handful of exceptions. Okay. But for the most part, there aren't many unit tests inside of Zen. I think there is there's a larger sort of system level test called OSS test, which is run. So basically what happens is we have, when we check it, we don't check things into a branch called master, we check into a branch called staging.
yeah.
And then every so often our automatic testing system will pull from staging and then do a whole load of tests. If there are no regressions, then it will push it from staging to master. Does that make sense?
Yeah.
And if there are regressions, then it'll throw up an error that has to be fixed.
Internally, we use somewhat similar. So whatever the comments that we are exchanging, like people are exchanging on the emails, right? So do they get tracked on the GitHub or somewhere? Like
no, it's all
basically
just an email, basically.
It's all emails.
Yeah, at the moment it's all email. I think, we're a bit of an old school project. We have a lot of kind of old school people, so most of the stuff is done over email. We're not necessarily opposed to having new things, but so it takes someone to actually work out a system and push through it.
So we do have a session also, so like the other stuff as well.
Okay.
So we're already 20 minutes late. So we have that design discussion around why maintainer and those kind of things. I think we cover some of the questions there. as well. We'll
Okay.
get into that.
Yeah,
There's
I'm
sort of
not sure I'll be
budgeting.
there, but we will be.
Yeah, but Wade will be there, and probably I will be there, and
Yeah.
pretty much anyone in the community kind of can answer some of those questions, right?
Thanks, Mark.
And I'll tell the other ones that this one is starting.
Okay, thanks everyone.
Thank you.